Hello everybody, welcome to chapter 4, session 3. So before I go to start the discussion of main topics, let me explain the differences between mass and weight. In junior classes, we already have discussed about mass. So mass is total quantity content of the body. Like example, if this is a body, then this body has got this number of molecules. Like liquid, these many molecules, and gas, these many molecules. So whatever the molecules the body has got, accordingly the body will have mass. That's why it is the total quantity content of the body. Whereas weight, weight is the force by which earth pulls the body towards its center. And it is measured by physical balance, this physical balance, whereas weight is measured by spring balance, because weight is a force, and we have discussed before, force is measured by spring balance, so weight is also measured by spring balance. And SI unit of mass is kilogram, whereas SI unit of weight is Newton, because weight is force. And mass means, already I told you, it is total quantity content, so they have just magnitude. It has value, but it has no direction. So that is why it is a scalar quantity. Only magnitude, but no direction. That's why it is called scalar quantity. Whereas weight, it has magnitude because it will have certain value, plus it has direction. Always the weight has direction towards the center of earth. So since weight has both magnitude as well as direction, it is called vector quantity. And mass, it depends upon number of molecules. Like example, let's suppose here 50 molecules are here. So if I reduce 10 molecules from here, the mass will change. So it depends on number of molecules. Whereas weight, it depends on gravity of the heavenly body. Suppose a body is same, and if you take that body to the earth and then we take to moon, the weight will not be same. Though the body is same, but weight will not be same. Why? Because gravity of earth and moon is different. Moon has less gravity than the earth, so in moon you can find less weight, and on the earth you can find more weight, and its value is constant. Suppose if we take this body, either you take it to Mars or you take to moon or earth, the number of molecules will be same. If the molecule is same, the mass will be same. That means its value is constant. It doesn't change from place to place. But weight, since it depends on gravity, and gravity is different in different heavenly body, so its value is variable. Free fall. So if you fall any object freely, that is free fall. In simple language, it can be explained in that way. So if you fall any object freely without any air resistance, then that condition is called free fall. Example, the astronauts in spacecraft, they are in the free fall state. Similarly, if you remember a video where I have shown you feather and coin experiment, in vacuum, if you release feather and coin, then the both will reach the ground at the same time. Why? Because they are in free fall state. That is why the definition is, it is a state of body when it falls freely without any resistance under the action of gravity. And when the body is in free fall, the acceleration of that body becomes equal to acceleration due to gravity. Astronauts in satellite are also in free fall state, as gravity of Earth is nullified by centrifugal force of satellite. So when the satellite is moving around the Earth, then the satellite has got centrifugal force. Centrifugal force means that the force that takes the body away from the center, and that force is cancelled by the gravity. So in astronaut, there is no gravity, and because of that, the astronauts are in free fall state. Is the fall of parachute a free fall? You know that parachute falls down. Can you call it free fall? Of course not. Because if we check here, it is mentioned here without any resistance. So when a person falls with parachute, then the parachute will experience a resistance. So we cannot call it free fall. So answer is no, it is not. In a free fall, acceleration of body must be equal to acceleration due to gravity, as we said before. But a parachute falls with constant velocity due to air resistance. At what condition will acceleration of parachute be zero? So acceleration means the rate of change of velocity. So when velocity does not change, acceleration becomes zero. So we already said here that after a certain time, then parachute will start falling in constant velocity, means in the same velocity. So that time its acceleration becomes zero. So answer is when a parachute falls, at first what happens? The velocity will be more. But after some time, then what? Because of air resistance, the acceleration of parachute becomes zero because it falls with same velocity. Weightlessness means no weight. So when a body is in free fall state, so when any body is falling freely, then that time body will have no weight. And this state of body is known as weightlessness. It takes place where there is no gravity. If there is no gravity, then there is no point of having weight because you already know weight is caused due to gravity. So where do you find no gravity, like in space or in center of Earth or in satellite or in geostationary zone of space? Here geostationary space means the middle point where gravity is zero between two heavenly bodies. And here the real formula of weight is mg minus ma. Normally weight formula we have taken mg, but actually the real formula of weight is mg minus ma. So when a body is in free fall state, what will happen? Acceleration of body and the acceleration due to gravity will be equal. So it will, if the body is in free fall state, what will happen? Mg minus m and a can be g. So mg minus m is 0. So that is the reason weight become 0. Are masslessness and weightlessness same? If not, why? Weightlessness means no weight. Masslessness means no mass. Is it same? Of course not. Masslessness and weightlessness are different because masslessness leads into weightlessness. If there is no mass, there cannot be weight. But weightlessness may not lead into masslessness. Means sometimes what may happen if the body is in free fall state, it can be weightlessness, but it does not lead into masslessness. The difference between free fall and weightlessness: it is the state of body in which a body falls freely under the action of gravity without air resistance, whereas weightlessness, it is the state at which weight of body is equal to 0 due to free fall of body. And because of free fall, weight is caused. That's why it is weight, it is cause, and it is effect. Sorry, here written weight, but you write effect. And it occurs in gravitational field of Earth. Free fall will occur within gravitational field of Earth, but weightlessness can be occurred within or out of the gravitational field of Earth. One question is here: the probability of getting hurt is more when a man jumps from significant height. Why? So you have seen when a person jumps from just from the 1 meter height, the person will not get any hurt. But if a person jumps from multi-story building, the person gets hurt. Why? So it is simple answer. What happens is when a man jumps from the significant height, he will feel negligible air resistance and somehow he falls freely, due to which he reaches the ground with increasing velocity, and because of that he gets hurt. And weightlessness in free fall and in space. You know that weightlessness can be occurred during free fall state also and in space also. What is the difference? In weightlessness and free fall, here acceleration of body become equal to acceleration due to gravity. But in weightlessness in space the body does not move, so it is almost zero. Weightlessness in free fall, it occurs under the action of gravity. Because of gravity, there is free fall and weightlessness is caused. But here, there is no gravity in space, so it occurs in absolute. You can do it. Thank you.